Alright, we're going to skip the subplots and the plotly stuff here. We'll come back to that again in the web mapping section, web analysis section, because it's kind of cool and you should know how to do it. But what we're going to move to now is creating the log logistics, which is an S-shaped curve. There are lots of S-shaped curves in the DRC package, and so we'll be using that. I'm just going to skip on down, skip past the extending the exponential, and we're going to come down and select this data here, this code here, where we create a Philly predict and continue moving through this. And right here are the models, and I'm going to grab all the way through here down to the plot and points and go back over into my RStudio and paste that in there. We're going to put in another comment here which says now we move to the log logistic fit, and that's just an S-shaped fit. I'll put some readings on the log logistic and maybe do a little video on what it means, but this is just a classic S-shaped curve that is being used in Corona modeling. So we're just going to assign our Y again in case it got messed up, just to remind you that it's Philly 2. And then the model that we're going to use is DRM, which is from DRC, which is stands for dose response model, and Y is our number of Philly cases, and the sequence is 1 to the number of rows of Philly and 1. And I'm going to select that and run it so you can see what this does. It just is 1 through 50 for the days. So we're using a day, so these parameters are per day. If we put the date in there, it would mess it up. And then this function that we're going to use is the LL5, which is the log logistic 5. And then we want to fix some of the parameters. And when we put NAs in here, it leaves the parameters free. If we put something in here that's 5 parameter logistic, 1, 2, 3, 4, 5. Like I said, I have a reading on what that means, and if you did the Excel ones, you can see what they are in the Excel because we actually do them there, but we're just saying don't set any of them to anything. When we put NAs in there, it says let the model do them all. So we're going to run that, and it goes very quickly. We could select the model to see what it did, and this is all it puts out. It tells us what those 5 parameters were, and lets us know that it was successful. Now we wanted to use the PR, which is the predict command for DRC, because it's slightly different, and so the Corona cases that we want to throw in there, and maybe I should put predicted in there, that would be a good idea. Our PR, the model, which we just did there, and the sequence again, Philly plus 1, it's the same thing. So it gives the number of days and then extends that out. So I run that, and it just throws the predictions in there, what we would have predicted from the model. And so we do that, and we see it goes to 102 days, and starting at 51, right, because we had our others. And so starting in day 51, it's telling us that eventually Philly grows to 31,000 based on this model. And then we're going to take the predicted from the model and the Corona cases that we just made, which are those extended past 50, so the predict from this model, right? If we run these are the predicted in sample. And it starts off at negative, which lets us know there's a little bit of problem with the model, but not so bad that we're not going to use it because it's fitting fairly well out here at the top end, which is what we're hoping for. And so we're going to put those two things together, and then we're going to create a dates sequence for plotting because people like to see dates, not days from. And then we're just going to put the C1 into predicted corona. We could have put predicted corona up there. The C1 is sort of an artifact of something I was doing earlier, and sometimes I leave that stuff in the code and I should not. And then the Philly predict one, we're going to put in the dates and the predicted corona. Again, I could have just put in this code there, and I'm being overly trying to be overly clear here by doing it step by step. It also helps when I make a mistake to go in and figure it out if I don't have everything stuck in one formula. So I can select the Philly predict, and that's going to show me those two. All right. The other reason for doing it into the predicted corona is then when I create that data frame, it calls it dates and predicted corona, which is kind of nice for plotting. I could have just renamed them. All right, so there is our predictions for Philly going off to 30,000 given this model. And then I'm going to plot the corona cases LM. Right, this was our exponential model that we did, and that's in the red, and the latest LogLogistics. So we see that they are very, very different. Our exponential model very quickly becomes not a particularly reliable model for how epidemics actually behave. Now, whether the safe in place, pause, Pennsylvania, any of that actually causes to flatten will be debates in master's and PhD theses for years to come. Let me go up here and hit a save. We're 6 minutes. We're going to stop here before we start playing with the model.